Hey, everybody, this is Larry. I'm in Hong Kong right now, but doing this weekly contest 178. Uh, excuse me. Wish me luck. There's 35 seconds to go. I have not practiced the last couple of weeks because I was traveling in Vietnam. It was fun, but probably too fun. That's why I haven't been doing these. So got a little bit rusty, to be honest, but we'll see how it goes. And yeah, I'm excited. And now there's still 15 seconds to go. Let's do this. Yeah, I mean, I think it's no spoiler at this point to say that this is probably my best contest ever, and probably will be the best contest ever anyway. Uh, so yeah, but very good contest. That's what I meant to say. But yeah, I opened up the problems, um, and yeah, the first one. Yeah, as soon as I looked at it, I mean, even the problem name tells you essentially what to expect a little bit. And I just wanted to look to see if there are any tricks. Are there edge cases that I'm looking for? Like, like the cases where two numbers are the same? Do you count them like strictly smaller or equal to? And I looked at the constraints. I was like 500. That's easily n square. So that's essentially what I jumped to now. And then it's just implementation. It's a little bit weird the way I wrote it, but it's not because it's a little not Pythonic, I think maybe not, I don't know. but it's still very simple to read, and there's probably like a one-liner in Python that you could do, but I just wanted to opt for typing speed, and typing speed, depends a bit on your familiarity with the language, and whatever you're familiar with, you're going to be faster. Not typing speed per se, but completion speed, I guess, is probably the more accurate. But still, I haven't done any contests in a month, so I'm going to test all the test cases, even though I was kind of confident about this one. I mean, if this is wrong, like maybe I have the science wrong. So,
Yay.
but yeah, Q2. Um, yeah, at first I thought this was one of those what's it called, ranked choice, which is not actually. It is just and you could Google up ranked choice elections, and I think that's just been a conversation in the U.S. recently. So that's maybe why my brain went there. But I read it, and it actually is purely given it like con- in my mind, it's just converting all these votes, sum them together, but converting these votes into sort of a vector for each candidate, and then sort by those, right? So, so yeah, so that's pretty much it. And I think the tricky part about this problem is just constructing the well, right, just the programming part, because I think the concept everyone could understand. I mean, it is just what they tell you to do, and from that, the programming part, the harder or the hard-ish part, uh, or the trickier part, is kind of to figure out the data structure to do it in. And this is where obviously having practice will kind of come into play a lot. And because it's, in a way, it's just manipulating arrays and lookup tables and stuff like that in a way that you can code correctly the first time and in as fast as possible, which is obviously easier said than done. Um, but but yeah, and that's why I'm also trying to be a little deliberate to, and by that I mean slow, no, but deliberate to kind of make sure that because what you don't want to do, or what I didn't want to do, was write something and then find out that like the data structure doesn't make sense. So I was kind of a little bit making sure that I was right, and I'm like I said, I'm also a little bit rusty, so uh, so yeah. And looking at the results, I actually took longer on this one than most other people did, but that's okay. Well, not most other people, but most people in the top like 20 or so, right? Um, because this should be like I did this in about 6 minutes, probably like a good timing that I would consider for myself is 4 minutes. But some of that is like I'm rusty and I wasn't familiar with the language. Like you see me kind of do like random things here, and not actually, and I have to do a print statement because I wasn't sure that that code actually ran either. Um, and I was trying to do also a little bit too much of trying to be too clever, and I actually end up dropping the cleverness a little bit for a little bit of if statements, which made which worked on the first try, which I was very thankful for because these things you never know. And here I'm just kind of noticed that we it's not always from A to whatever character. It could be any. So I just keep track of the candidates that are in the contest or election or whatever this is. Um, yeah, and then now I do that thing of the lookup table that I mentioned. And now you have a vector of 26 ways from A to Z, and then just yeah, and I'm just printing these out just to see if what I'm doing is okay, and it looks okay, so I'm going to keep on going. And now I'm trying to figure out how to do the sorting. I was like, okay, convert the set to a list, and then now I have to figure out the key. The key part, this first part is easy because you can sort by the array, but then, well, but then I thought I was just gonna reverse it, look up the and but then I thought about the tiebreaker, the last tiebreaker, which is the alpha alphabet order. So I was like, okay, how do I kind of handle this in a well, essentially not dumb way? um, but yeah, but I thought I actually wasn't sure that this would work. Basically reversing the ordinal value with, is like a double reverse on the ordinal as a tiebreaker. But I just wanted to give it like I thought I had enough to at least test this, so that's what I essentially did. I think that's where like a couple of minutes are coming from the tiebreaker. Actually, I was just really careful about it because to be frank, was not confident about it. But here I did notice that on one of the examples, the fourth one, um, it does test that case, which I'm very. I mean, I would have constructed one, but I was very thankful in either case that that was one of the case. That gives me a little bit confidence, though. Sometimes it's still, or at least for me, I'm still. You never know. I never know. Um, but yeah, once that's okay, I was like, yeah, let's give it a go. Like I'm rusty. I didn't expect that much from this contest, to be honest. I didn't, in a weird way, because I have lower expectations. I didn't really put pressure on myself to do that well. If that makes sense. Um, and that actually, and then I just kind of, because it's way easy for me to get a 5 minute penalty on these. To be frank, because I wasn't, you know, like I don't know, like I just haven't been practiced, right? But yeah, Q3 linked list in a binary tree. I think I was just reading this immediately, and I misread. I mean, not a misread. I just kind of started with some template code, or not template, just like to kick me off. I thought that initially when I first started this, that that you can only start the linked list from the root, and that makes it kind of trivial if that was the case, because you check to see, if the first element matches the root, and then you go on, and then you check the left and the right and so forth. Um, I think looking back, I didn't even prove this to be correct. So this is actually a little weird because there are, you could definitely construct exponential cases that would fail, but then I don't know. That's why some Leetcode problems are a little weird in that regard, in that like you give it your best shot and then hope it's good enough because sometimes it's not. Because like the worst case, it might not be good enough, or like it's definitely not good enough for the first case. So if you just have all the numbers the same except for the last element or something like that, then it would keep on going, right? Something like that. And you could definitely construct something that makes it like 2 to the n. Is that true? No, I guess that's not. Maybe maybe I'm mucking it up, my explanation, because I think no, because you look at each node. Yeah, actually, this should be okay. I think I misspoke now that I think about it. But at the time, yeah, I was just focusing on, I guess my intuition was better than my thinking about it. But yeah, here I was like, okay, what does it? So initially, I solved the problem of with the linked list, or yeah, with the linked list starts at the root of the binary tree, and now I'm making modifications to kind of see what happens if that's not true. So one thing that I did do here, if you notice, is that I do still want to test because I know that, for example, 2, like it should at least give me a true. If example 2 gives me a false, that means I have another bug somewhere that I should debug before moving on. So a little bit of a TDD type thing, and kind of able to break coding this in pieces. But otherwise, yeah, I was like, is this enough? I didn't think this was enough because now you can, because the way that I did this is I don't keep track of whether you started, because once you start comparing it, once you match a node, you would have to keep matching, right? So you can't just like, it's not what they call a subsequence or whatever, where you could skip over nodes to keep matching, right? It's not, because if that's the case, then this code is good enough. But because this is not, I have to add an extra dimension, whether the linked list comparison has started. And if you do the math, and I didn't do this, I mean, I think some of that is that intuition from practice, which is that I know this is going to be n squared, so because for each binary tree node, you can start with each list node once, right? So that's O of n times m, where n is the length of the binary tree node and m is the length of the linked list node, or linked list and binary tree, respectively. And then now I'm just trying to figure out, like, well, what are all the possibilities, right? Well, and this is basically all my if statements are doing. It's kind of enumerating all the possibilities. There may be a slicker way to kind of put this together, to be honest, but I wanted to see if this worked, and once it works, yeah, I'm done. And you can maybe even cache it, but okay. Cool. Yeah, the last one. Minimum cost to make at least one write path in the grid. I think we've seen, or I've seen, even just on Leetcode in the last, like 10, 15 contests or something. There are a lot of these type of grid problems going, where well, I mean, it's just a variation of shortest path, and you have to figure out, yeah, it's just a variation of the shortest path. I mean, or rather, it is just shortest path, and you have to figure out how to convert it into a shortest path problem. Maybe that's a more precise way of saying it. And here, yeah, it seemed to me that, well, the cost is 0 if the arrow points the way you're going, and the cost is 1 if it's not, because you have to change the arrow to go where you're going. And that's it. And you never, and the key maybe point here is that you never need to revisit the same cell, right? So because of that, you just have to visit, you just have to keep track of the shortest path to every current cell. And then from that, figure out the best path to the cell in the corner. And I think you could do it in a couple of different algorithms. I did it in with what you might call it. I did it with just regular dice drawer, mostly because I'm really familiar with it. I have something that for years, and I know how to code it. Even then, I'm a little bit rusty. But a contest is not, or a contest where you know a way to solve it, or a problem in which you already know a way to solve it is not the timed experiment. Just do it the way that you know how to solve it, right? Like, because I think you could probably do this with 01Q, BFS, but I haven't done that, just in my career, I haven't done that enough to kind of be confident about it to whip it out on a contest. I mean, I would go and do it if that's the only way to do it, but usually the difference between the two algorithms is not, like linear versus n log n is not that much of a difference. Where where n is the size of the input in this case, which is the entire grid, right? Um, but otherwise, the rest of this file is regular dice drill. I checked to see. I think the thing that oh yeah, I think the only other thing that I was thinking about while solving this was like if the colors of the arrows mean anything. Because I keep on looking up, I'm like, what do all these colors mean? Why do they do this on the problem? And I wasn't sure. Oh, I should have turned. If there's a light like there, I should have turned it on. Then it would have. Oh, well, it's too late. It's fine. Is my face better lit? I don't know. Anyway, but yeah, but otherwise it's just straightforward. You know, I do use a couple of shorthands. Not shorthands. Maybe that's not the right word, but just like patterns, shortest path patterns with the directions, so that I can kind of check easily. I'm doing this thing here because I don't. It's been a couple of months. It's been a month-ish. So I'm rusty with Python, so I don't remember exactly the unpacking rules. That's why I have some like weird thing just to test the unpacking. And I say I didn't really have pressure on this contest. So I was just able to just take my time and get it right. And yeah, as I said, like the cost is 1 normally, and cost is 0 if what you call it. Yeah, the cost is 0 if you're going the way that the arrow is facing. And here as you can see, I'm a little bit rusty, so I'm actually pretty deliberate about it. Otherwise, I think I would have saved maybe a minute or so, but that's fine. Like I really wasn't pushing for it.
We're not practicing enough
for speed per se on this one, which ironically is one of my best contests. So I don't know. But I would also say if I had gotten one wrong, then it would have knocked me down a lot in ranking. And these are just right now very standard. I even do a little bit of optimization, moving some of the if statements inside the easier if statement. But it probably has no performance difference. It's just kind of like what you might call it, like it just looks ugly otherwise for me. But yeah, but it's just setting up the dice trend, and now I'm trying to figure out the default value, which I think you always reach every node. So I don't think this is ever going to hit, but I just wanted to double check just in case there's some like unreachable state or something like that. And then I just check the final if statement, and that's it. Cool. All right, friends. Thanks for watching, and thanks for the support. This is my best contest ever, obviously. So yeah, lots of luck. Bye-bye. Or stay tuned for the other guy. Okay. Whew, not bad for having done it in a month. But let's see where I get it. Oh, people are fast. 14th or so, not bad. Yeah, I mean, clearly my best contest in a while. No matter how wherever I end up. Cool. Actually, is this we updated? I don't know. Uh, maybe I should do every contest from Hong Kong, right? But okay. While I wait for this to get updated, let me go over the problems real quick. Number one, how many numbers are smaller than a current number? So yeah, so this is, I just did n square, n was 500, and then, yeah, I was actually debating changing language doing it just because it's easier to write for loops in other languages like that. It's not easier to be, what I mean to say is that it's easier for me because that's my background, is easier to write those for loops, where in Python, it's easier to write or think of things in terms of for each loop, at least for me. But obviously, as you see, it's not that bad. N square just did it. There's not much to it. Ranked teams by rows. This one I had a little bit, just try to figure out in my mind the right data structure. But I mean, I think otherwise it's just following the rules. I think I also had a little bit kind of concern about the tie breaking stuff because I'm trying to do reverse of it. Maybe I should, like, I could have probably done a negative of this lookup array, or I guess -1. That would have been a little bit clearer. Then I don't have to reverse it. But I'm glad that this worked out because I actually wasn't super confident about it. But it's just follow the rules from, and the hard part is just getting the data structure right. And then after that, using that as a lookup key for sorting. Linked lists in binary tree. This one's a little tricky. I think there are potential edge cases, and that's why I kind of slowed down a little bit. I end up taking about 5 minutes on this one. Yeah, I think, well, initially I thought that you could start, initially I thought that you could start only at the root. That would have made it a lot easier, obviously. But because that you can't, and you can start anywhere, I have to add in this auxiliary variable started to see if it started, which it is what it sounds like. And because you could only start at each node once, or each node can only be started once, this ends up being n square, which is not, I think it's something, I mean, it's quote unquote obvious to me in that I've done a lot of practice and I know how these complexities shakes out. But it is something that, yeah, and there's some like natural pruning and stuff like that. But that's kind of the logic, and it is kind of a little bit tricky in thinking that maybe it could be exponential. But yeah, I end up being n squared, so then I end up doing this way. And there's some weirdness, and there's some like cell pruning property that makes this obviously slightly faster than n squared. But maybe even the test case is a little weak because 2500, I think, maybe cutting it close. And maybe it's not even n squared, so where it could be the length of the binary tree times the length of the linked list. Now that I think about it a little bit better, and that would probably make it one in time way better because for each binary tree node, it can only be in one of the position of the linked list. So then it ends up being the length of the linked list times the length of the binary tree. And that actually makes it very fast because 2500 square is probably a little bit slow, but for Leetcode anyway. But 2500 times 100 is way fast. The last one, minimum cost to, yeah, this is I think you could probably do it in a couple of ways. There's that other technique, the 0, 1 queue and stuff like that, which I'm aware of, but I don't generally do it because usually the constants are not necessary. Like the speed up that you get, I don't, like the speed up that you get from O of n or n times m, depending on how you want to define the n, but the linear input times like a log factor is not enough for me to go outside my comfort zone with this one. But I end up just using a priority queue where actually I wrote the code. I'm a little bit rusty because I haven't done Leetcode in like a month or so. So this code is actually like more readable, versus like everything's in my head. I'm like more steps ahead, and then this would be a slightly more unreadable. Um, so yeah, I just calculate the cost. I check that if it's the direction that's already going, then the cost is 0. Otherwise, the cost is 1 to change it to the direction that you want it to go. And then you just do, do the shortest path. This is a very standard problem from that on. Let's see where I end up ranking. Fifth. Wow. Huh. I mean, I actually did not expect that, obviously. I mean, yeah, I mean, apparently I should do every contest in Hong Kong. That's my that's my takeaway from here. Yeah. Well, I mean, I don't know. I mean, this is probably, to be honest, this is probably the best I'm gonna ever do. So yeah, let's end it there. Thanks for watching, and wow, I mean, I feel great. Bye bye.